Sorry, I'm late. Sorry. Ooh, IMX219. Zephyr drivers, IMX219. IMX219. So, hi everyone. I'm sorry I'm late. It's a really confusing day. I've been having problems with my machine. Well, not really problems with my machine. What's been happening is I've been setting up my new machine and I'm in the middle of migrating in between them, and so it was just a little difficult. But we're here now and we're going to do this stream, and I think it's going to be one of those ones which ends up being a really good stream. So let me see if my audio is good. I think my audio is good and I think everyone's here. So let's get started. What do we want to work on today? Today we have this. So previously we worked on the IMX. How do I say this? We worked on the getting the IMX219 to work on the STM32 N6, and actually, to be honest, it's gotten so far that I think it's there, it's working. However, now what has happened now, what we realized in the video community, is that the video driver, this PR that we kept using, has fallen behind. And what needs to happen is that it needs to catch up. But anyways, let me run the application as is right now, and then we can see what is happening. And then once we see what is happening, we can start actually fixing it. I got quite a bit of help from Elaine of ST in the Zephyr video chat. And if you go there and you can look at the threads that I've been sharing, you'll see what we've been discussing and such. So let's actually just pull off. There's been some changes here, obviously, and we'll explain these changes. Actually, I can just go and I can actually revert them so that we can actually work on them. Whoa, that has to change now. That has to change. I'm very sorry about that. Oh, yeah, that has to change. I'll have to change that. But you don't know where I'm using it, though. You don't know where I'm using it, and you don't have the private key. You just have the public key. Now that's cool. That's fine. Okay, cool. So let's run the application, and then once we run the application, we can kind of start looking at stuff. So first thing I'm going to do is I'm going to change it back to what it was, and the thing that I need to change is this line height and line count. So pf no quit. Yeah, sorry, I'm just IMX219.c. Can I get that one? Yeah, this. And I think the two lines that what was they? This was somewhere in line. I think, what is that? Get cups. Let's do get cups. Get cups. And yeah, I think it was here that I changed it. Yeah. So this is the thing that I removed. So these two lines is what I removed. These two lines is what I removed here, and I'm gonna put them back, and we're gonna run the application, and then we're gonna see actually what the issue is. Then we're gonna start debugging from there. Okay, cool. So let me put this back where we left off last stream, and then this is obviously a git marker. We don't want that. I think that's it. If I'm not wrong, that's no. Yeah. So I think that's it. And why is that not highlighted? But that's for now, we don't know. And then we're gonna source. So I'm gonna source backwards, and then it's gonna be env bin activate. Let's do this. So cool. And then this is gonna be west build. I can actually just remember that. West build. Not that one. Build dash b Nucleo samples driver capture. Yeah, let's build that one. And then let's put a little one on the side here so that we can do the what is it called? We can do the logging from there on. I don't think we can do something like picocon or something. Picocon dash B115200, and then this one can be dev tty SCM0. I think so. I think this should give us LED on, LED off. This it was running the blinky earlier because I was testing it on the new machine. But let's actually build it and let's flash this, and then we'll see. And then we can actually start working on this driver, and then we can start actually going through the issues so that we can work on this driver and see what happens. Yeah. So introduction. Hi, my name is Zach, and I'm a Zephyr developer. I'm an open source developer, and I work for a company called Tiny Vision most of the time. I own another consulting company called Guyouch. I do a lot of live development. I share information. And what we're doing today is being sounds PR, and we are unstalling it. It had gone stale because they got busy making Zephyr awesome for everyone else. So we're gonna try and build up on what they've done and see what we can do. Amazing. Yeah, exactly. So this is the first. This is going to be the first issue. So the first thing is that unstalling, not uninstalling, not or installing, unstalling. It had stalled. We're making it not stall now. Unstalling. We're basically driving it forward. It was stalled, so it's not stalling. So the first thing I want to do is check. This is as such, and this would look like line 284. 284.8. No. Which line was this? So I removed this caps min, caps max. Let's actually just look at this driver. Let's look at this driver as it lives and find this line in the driver and see where it is right now. So I'm gonna look at the IMX219 here, and I would like to view this driver, view file, and then in here what I want to do is I want to find those lines. So Control F, and then if I could do that, Control V, then I could do that, and then I just want to find it. It's in line 287, caps line mix, caps line max. Okay, cool. So that, yeah, caps line mix, caps line max, and caps mean line 287, 288. So is that where I added them back? 287, 288. I do not understand why this is now throwing an error. However, I can now start explaining. So with the new Zephyr 4.3, the video subsystem is getting quite updated. It's becoming quite a lot beefier. And what is happening now is these capabilities have now been removed. They're done somewhere else. They're either done on the application layer or not. So the thing is, the thing that happens here is that they get removed. Like, unfortunately, there's no interesting part here. But as Elaine explained, again, remember, you can always go into Discord. No. Yeah, I'd like actually to do that. I'm going to Discord. I'm gonna drag the window over. I'm just making sure I'm not in a place where I cannot share. You can go into Discord, and you can find in the Zephyr Discord, you can find the video channel, and then you can see there's a Nucleo N6 DCMIPP plus IMX219 thread where Bartholomew, Joshua, and Elaine have been discussing. And the thing that happened is we realized that these two drivers basically they become overwritten. And an interesting thing we can actually do is to rebase this driver on main. But this is sort of what we're doing already because this branch is already rebased. So the first thing we need to do is remove these, and we can save that. Once we save that, we can now start running. Let's see if this actually builds all the way. I know I'm rushing because I'm late and everything. So I'm trying to kind of go back to my normal cadence of doing stuff. Does anyone have any questions so far? Anyone have any questions so far? Please. Questions are very welcome. You can ask, you can take me back to the beginning if you need me to explain this from basics to you. If you're doing anything strange, you can ask about it. Just ask. This is the forum for you. I like how Bartholomew goes, "Are you ready for an epic stream?" I'm like, wow, am I ready? I think Bartholomew is ready, but I don't know if I'm ready. Okay, cool. So let's see if this builds all the way to the end, and then hopefully it builds, and once it builds, we can start actually talking about it. We're very close. We're very, very close. Very, very close. I reckon it's close, but I've done this before, and sometimes it wasn't as close as I thought it was. So, number one, it built all the way. So let's put the actual device in bootloader mode. That's odd. So I just tried to put it in bootloader mode, and it didn't go into bootloader mode. What is happening here? Okay, it's in bootloader mode now. So the device is in bootloader mode. I'm complete opposites today, and I'm gonna flash this. Wait. Before I flash it, can we just do that so that we have that ready? And then I'm gonna do a West flash. And then as it's flashing, I think it's gonna succeed. I'm gonna change to what does it say? No, Bartholomew, I'm on the old machine still, and it's good to know that the code cuts off. I think I haven't moved over to the new machine yet because I had to set up YouTube. That's why I was late. I realized I hadn't logged in on OBS on the new machine, so sorry about that. And then it would have taken, like, I had to do like a refactor, two-factor authentication and all of that stuff. It would have taken too long, and then I would have been too late. Okay, cool. So now we're actually getting somewhere really nice. So the thing here that is happening is that the Zephyr is moving towards an API that looks like V4L2. V4L2 is this. So Zephyr is moving towards a video API that looks like this, V4L2. So video for Linux. This is the API, because what we are aiming to do is we are wanting to ensure that the Zephyr video subsystem is interoperable with other existing how do you call them? With other existing systems, and especially in the age of today, in the age of AI and stuff, where there's a lot of people doing machine vision. You have a little microcontroller. That is doing that is actually at the edge doing the vision, and then it's collecting all the frames and it's collecting all the videos, and sometimes it's running some sort of inference, sometimes maybe not. But then this microcontroller might be connected to a bigger, like a Raspberry Pi, or like some sort of single board computer, or some sort of like GPU subsystem above it that is going to consume this, like say there's 5 microcontrollers collecting data from 5 image sensors, and then they push all of this, they stitch up all these image sensors and they push them up to some GPU, and then this GPU joins all these images and stuff. So you want some sort of interface that goes all the way from that goes all the way from Zephyr, and it bubbles up on the all the way through into bigger subsystems. And the bigger subsystems right now we're wanting to be compatible with is Linux. And other than that as well, other than making a pipe that goes all the way from a microcontroller all the way to Linux and then to the cloud and farther and beyond, Linux has spent a lot of time building their video subsystem. They've done a lot of research. They have a lot of cameras, image sensors and such. So they have this mature way of doing things. It's sort of like, consider something like DTS. You know, instead of finding a way of defining devices and pin control and what pin goes to what screen and all of those things, instead of finding a new way, what you can see in the ethos of Zephyr is that they adopted something that existed and they went with it, so instead of making something new, you can always build up on something that has already been done, just like we're doing on this PR today, on this stream today. We're working on some work. We're standing on the shoulders of giants. We've taken something that someone has done and they've gotten so far with it, and we just have to do a 5% or a 6% just to improve on what they did or complete on what they did. And you will find that in life, if you do this a lot, you will get much farther than trying to be someone who does everything by themselves. So there is value in standing on the shoulders of giants, and one of the reasons that the video API for Zephyr is going to start looking like the video API for Linux is we can stand on the shoulders of giants and we can use the sort of information that they've gathered over a few years. Entailed in that is that the story that comes there is that here we can see that the DCMIPP video interface, or rather digital camera interface pixel pipeline, that's the PP at the end of DCMI. It's a new pixel pipeline from ST, and what we can see here is that it is complaining about a source link frequency, and this is something that comes from this is something that is defined in the Zephyr in the video CID. Let's just do CID. I found it already. Video link frequency, so source link frequency, and there's something in Zephyr that already implements this. Come on, V4 L2 V4. Yeah. Sorry, I had to jump into the thing. So here it is. Let's look at it. What is it? It's 7.1 or something. I remember it. 7.1 or something. BCSI, and I'm gonna zoom in so that people can see. And then link frequency. The V4LD. I'll open that in a new tab. We'll look at it, but let's look at it here. We'll open it in a new tab. The V4L2 CID link frequency control is used to tell the receiver the frequency of the bus, i.e. it is not the same as the symbol rate. So this is kind of like, it tells, Alain explained it really well here. So let's actually look at Alain's explanation. What was it? Basically, you need to add a new control in the driver that you can take a look at the IMX219 for reference. It's a very similar thing. I don't know if you guys can see this, but let me try and zoom in, but I don't know. Oof, that's way too much. My machine is slow again. Basically, you need to add a new control in the driver. You can take a look at the IMX335 for reference, and a very similar thing. The link frequency is a read-only control which allows the receiver to know what is the frequency of the camera serial interface. Remember, we covered this from in the MIPP basics, in the camera serial interface link in the format, basically. So So the CSI driver should be able, the CSI driver expects us to tell it this link frequency. A control used to tell the receiver the frequency of the bus. Drivers that do not have a user configurable link frequency should report it through the get mbus config subdev pad operation and the link frequency field struct of that. But we're going to look at how Elaine has done it in Zephyr. So let's go and look at where Elaine sent us. GitHub, GitHub, Zephyr project, Zephyr, and then we want to go into, let's open that. And then we want to go into Zephyr, into the drivers. I think we want to go into video. And we want to go into the IMX335. By the way, the IMX335 is one of the most compliant video drivers right now. It's done by Elaine from SD, and it's been done like a Linux driver. Elaine has a lot of experience already with the Linux kernel drivers, so it's good to learn from him. So let's go and look at it. And if you need a complete driver that follows the new because the video API is changing, and it's changing a lot. So there's some old drivers and there's some new drivers, and what you want to do is you want to implement a driver that feels and works like the newer ones. So here we go. So we want to look at the link frequency. So Control F, link frec, unsupported ink frequency, ink, ICK. That's odd, yeah? Odd. It's all input clock, so that's not the one I was looking for. So frequency, let's look at the next one, clock frequency, and then let's try and find, actually I'm gonna go look at the callbacks for the driver itself, see if we can find one. Frame interval, control, set stream, caps, format. I think it might be in control, but let's look through. Analog gain, exposure gain, CCI reg, that's fine. This is not the ones we need. We don't need any here. Get caps, get format, set format, video reg. These ones are just registers. This is the stuff that makes this driver look big, but it's not really big. It's not that big. Controls. Pixel rate, but I don't think it's a pixel rate that we want to report. And does this have a H? There's no H. Okay, cool. So let's just keep going. For an example. It's somewhere here. We just need to find it for ourselves. Set format, get caps, okay. Set stream, okay. Control, set exposure. Data controls, that's fine. There's nothing there that we want. Control exposure, that's fine. This is all messages to the driver itself. Analog gain, CID exposure, that's fine. Only 30 FPS, that's fine. This is the frame interval, enum the frame interval, set format, get format, set control. Let's find input control, input clock. So what are you looking for? Init controls, let's see which controls are here. Video controls is a CID analog gain, CID analog exposure, CID exposure, CID pixel rate. I wonder if this is a pixel rate, but it says clearly here it is not the pixel rate, not the same as the symbol rate. Let's see. Let us see. Init. Let's look at init. Yeah. Does the driver have like some config in it that tells it what? So let's see. Pixel format, width, height. That's the struct. Get reset, input clock. That's it. There's an input clock, but it doesn't. I don't see a setting for the for the pixel rate. The only setting I see here is the pixel rate, and I wonder if that's the one. So let's actually look at the IMX one and see if IMX one, and see if actually there's one here that frame interval, set stream, CCR reg, CID exposure, analog gain, CID dot, get carb, set carbs. I don't see a pixel rate. Perhaps that's the one we're missing. We can also go and look at where that error is coming from, and we can find it from there. No, look, set input clock. There's one here. But this is just setting the input clock. Nothing reports it back. Let's go and look. Frequency. So let's look. Unsupported input clock. This is where is this? Input clock. Let's look if ours has input clock. Input clock hertz. It's there. Clock frequency. It's right there. So there's nothing. That's not the one we're looking for. Let's look CID. Analog gain, analog exposure, pixel rate. Do we think it's a pixel rate? Pixel. Can we look rate? So controls, CID set control, and then look at here, video init control. Where's this function? Return video init control. Where's video init control? I'd like to see video init control. Video init control. Yeah, sure, there's one here. And then this has all of those. But, okay, control that. Type integer. I'm looking at this. This isn't video controls. No. I don't want to look here. I do not want to look here. I wonder if it's a pixel rate that we just need to define. I wonder if we just need to define the pixel rate. Okay, let's see that. Where is it used? Main64. What is this that returns init control? Init controls. What do you return? So what do you return? Okay, the other part we can do is go look here, go look here. Let's go actually look at where error STM32 DCMIPP failed to receive. I can just go do this. I know it's in this DCMIPP driver. Actually, I know I can find it. I can just DCMIPP. Yeah, it's here, and then it's gonna be what is it? What is the error? Let's actually see what is link frequency. Let's actually see what it's looking for. Link frequency. A 5 bitrate. Where is it getting 5 bitrate from? A 5 bitrate. Where are you getting the physical? It gets CSI link frequency. GD. Get CSI link frequency. Video CID link frequency. Whoa! Whoa! We just found it? But this is in video common. This is not in this is not in the driver that we're looking for. So that's fine, that's fine. IMX 335 35 so frequency, okay. I think it's a pixel rate then. So okay. R okay, and then Control A, Control E. Okay, cool. Start with E. Yep. IMX. Whoa. I'm IMX219, so we can jump between it. Space A, Control E. Okay, that's PB. Okay. Yeah. DCMIPP. Space A, Control B. Okay, cool. So let's think about this. So this one has a pixel rate. I wanna see the pixel rate. Pixel. Let's actually use GitHub. It's easier if we look on GitHub. 2 days and I just forget how to use this machine completely. So let's go and look at this pixel rate, okay, and then let's find the next one. Where's the next one? Video unit control, video CID pixel rate, and then there's this control mean, max, and this one's. I think I know what the pixel rate is. It's kind of this clock that we give it. It's this clock that we give it. Yeah, I think so. It has to be. Zephyr. Let's go to our fork of Zephyr and then let's look at that branch. Let's look at this one. Let's actually look at the let's in here. Let's look at this IMX219 and then I want to see what is ahead. What does it have? Any questions? I have more questions right now, but does anyone have any questions? I think this is a pixel clock. Actually, let's go back. I have a feeling this is a pixel clock and this might actually fix it. Be fine. Okay, well, that's fine. I see. I have a feeling Look at this clock frequency. This, I think this is our pixel code. So that's 24 million. This one. So input clock. But let's see. What is the difference between that and this? If I go here. Yeah. In its menu control, we take a test button. We're providing a test button. Okay. And then after pixel test button, we do CID test button. And that's returning that. And I'm wondering whether we should just try and return. If this is giving back a test button, should we rather try? Wait, but look, is this? Isn't this what we're looking for? It is, yeah. It is, yeah. I don't see it. Let's actually go back to Zephyr itself and actually search something. Let's actually search. Sure. Let's actually look for a link. Let's actually get in here. And then in here. Link. How many drivers implement this? How many drivers implement this? That's a big mess. That's a big mess. What did we just find? We found a link frick. This one. Link frick. What if I just go to actual Zephyr itself? Maybe. It would be nice if I could just go and search the Linux one, because I might find something there that actually works, but I don't know. Video command, GCSI, link frick. Let's look at you. I know this is one of Joshua's favorite ones, and I think he's been working on it. No, just relax. Link. Okay, first of all, let's do link. Frick. Can we go like this? Can we go like this? Can we go like this? Because this is quite close to what we have right now. And we do have this ID. And I think we will find this, and we can't find this. So actually let's go and look at it. Let's go and find, yeah, we do have everything on here. So let's actually go find, and this is going in init controls. Perfect. And this is all happening after. So let's actually go and look at init features. And then in here, we want to go almost to the bottom here. It's all down here already. It's all down here already. What if we just remove the test button and see? I'm not so sure this will work, but let's see. Okay, let's try and build it. I'm gonna avoid talking while it's building, because if I talk while it's building, then I'm gonna I'm not talking. That's fine. It's okay. Oh. Okay, cool. So it built. Let's see what happens now. Let's see what kind of log we get right now. Let's see what kind of log we get. So I'm gonna put the thing in bootloader mode. Press it here. It's in bootloader mode. I should here, and then from here we should be able to flash it, and then we should be able to see what happens. Let's see. Is that it? Oh, I know it. I know what happened. I'm gonna replace it here. I'm gonna reset it. Yeah, come in and take them. Sorry. We needed to hand over some house keys. So that's actually not the solution. So now let's actually figure this out. Why can't it read the link frequency? Is right there. And clearly just reporting it is not the solution. So it's been set already, but I don't see a callback. I don't see any callbacks in here that report this link frequency. Let's go through it. Yeah, cool. Yeah, that's it. I don't see a link frequency callback. It seems like this should return the And we're passing it right into it, so it shouldn't be a problem. But why is the STM32 not finding it? Shall we just go ask the questions in the group? Let's go see if we can ask the questions in the group. We want to look at IMX219. Actually, where's that PR? Where is that PR? Yeah, so init controls. Init control. Let us go stand on the shoulders of giants and see what happens. And then I can take some questions. We might have to stop this. This is quite cool because now we're digging. And I like digging, and it's just late in the day. If I could have started digging earlier today, then it would have been fun. Then I can go for 5 hours, but it's quite late in the day already. So it would be quite unfair to go digging right now. I spent most of my day fixing up my new computer, and that's why I'm late. I should have done this in the morning, but I need to fix up my new computer for work anyway, so it has to be done. Okay, cool. So yeah, let's look at this. Copy button. Seems to me that the link frequency is already reported. So cool. So while someone there, we might not even get an answer today. While someone there is trying to answer us, let's look at the Linux part of it. So, should you get link frequency helper to obtain the link frequency from the submitter device? And this should be in the VL2 mbus config. It here config parallel CSI. Yeah. Link frequency, it's in the config. It's in the config, and I think if I'm not wrong, it's also in the config here. It's also in the config as well. Config. No, sorry about that. It's also in the config here as well. So let's just go looking. Let's go looking. The config is usually at the top. I can see how slow my internet is. This is just 500 lines of code, and I don't know why this is big. So yeah, look, link frequency is in controls, and controls are going to be okay. Cool, that's a difference. So let's actually look here as well. So I want to see the config. Go to the top, control exposure. I think this is mostly control, and then the actual, this is the GC. Yeah, this one's a huge one. Most of them are not big because the driver is big. They're big because of register definitions. They're not that huge. They're not actually that huge. Sure. Does anyone have any questions so far? I think I've just planted more questions in your head right now because I didn't do actually. Oh, come on. Give me a config function. See, okay, see. This is where the difference is. This one has a MIPI, okay, config, the I2C spec, GPIO spec, GPIO spec, controls, that, and then in the controls there's a video control link frequency, and that's it. And all we need to do is set this guy. This has been set here, this has been set here, this has been set here, and this has been set here. There's nowhere else. It appears nowhere else. So the interface gets it from the driver, from the control availability. But somehow the STM32 DCMIPP does not find the interface we need. Let's look at that again. Failed to configure input stage. Failed to retrieve source link. Let's go look at this in Zephyr. Does anyone have any questions so far? Or comments? Questions or comments? I'm probably gonna stop this one at the hour mark so that we can discover more. No, not that one. I wanna go to the Zephyr, not here. I wanna go to the Zephyr itself. Sorry. Should be somewhere. This is video STMIPP 02. No. Oh no. But let me see. Is this DCMIPP? Which module is this? Log define, log modules. MIPP. This is a MIPP. This is not the one we're looking at. This is definitely not the one we're looking at. We're looking at this because look at the logs we're looking at. It's STM32 DCMIPP. So it's gonna be. Let's look at the log definition here. Don't do that. I don't know why you're doing that. This new GitHub interface is being silly. Log module A, STM32. Okay, cool. So Control F, Control V. Let's see. Failed to 5 bitrate. Where are you getting this from? Video get CSI link frequency. Config source dev, video bits per pixel, DCMIPP that, config CSI NB lanes. And then if 5 bit rate is 0, so _0, so it's looking at the source device, and then it's looking in its video bits per pixel. Where is it? Where's this function? Video bits per pixel, and that's taking in the pixel format, and then it's taking the CSI NB lanes. Okay. Oh. We're looking at two drivers. We're looking at a few drivers. So we're looking at the driver for the IMX. This is a camera. And then we're also looking at the driver for DCMI that's inside the device. But then we're also looking at the driver for this CSI interface. This little interface, camera serial interface. We're also looking at that driver. So there's a few places this could happen right now. It might not even be in the IMX driver. Basically is what I'm saying. Let's look at that. So get CSI link frequency. Takes these three and does what with them? Who are you? Where are you? Where are you from? So you're in video common. Let's go and look at you. What do you do? Where do you look? Okay, cool. So it goes video control, that ID. So it takes in video control. ID is the video CID link frequency. It makes two structs. Control query. Cool, that's fine. Device and video link frequency. And then it tries to get the link frequency from the source device. Video control, get control and control. Fine. It gets the control. That's okay. And then video query control query. So okay. So it gets this control with the ID that. So what are you telling me? Are you telling me I need to define a video control with that ID? I think that's what you're telling me to do. So I need to define a video control with this link frequency ID. So let's actually look in the IMX335 and see if that makes any sense. ID. No. Sorry. Yeah. Control F ID. Let's look at that. Let's look for that. No. What is this? Why? Space and probably space before. Okay, let's look at that. Maybe not. Maybe no space before, but definitely a space after. .id. Okay. Let's look for video controls. I want a video control that. Gain 38. Controls gain value control. Okay. And then I want to look at the 2C145. I think we are kind of getting close with it, because now we're kind of getting to a place where we can. So you see this ID.id, video links, video CID link frequency. Is it you I am looking for? Is it you I am looking for? So let's look. Okay, and then we also need to see who this is. So yeah, can I open you in a new tab? What do you do? That hurts. This, when you sit like this, when you stretch your neck towards the computer, it hurts. You get like back pains. So try and avoid doing that. Okay, cool. We're getting it. We're finding it. See, control dev ID. There you go. I bet you this just makes a struct. Yeah, you see, this one just builds a struct. It takes the ID. Yep. ID. Yeah, fine. So somewhere, we need to pass in this as an ID. Return video control ID. That's fine. But this is already being done. Video CID link frequency. It's already being done. It's already being done. So It's here. So you see this, when it's the third item, that means we're making this. And we're making this and we're filling it with all of these. So it's going to fetch it from this one. It makes it in here. And that's the third one, that's the one that gets used somewhere. And this comes and gets used here. So somewhere else it's missing. Somewhere else it's missing. Wasn't that video common just now? Yeah. So let's go backwards. Yeah. Did we do a Control F here, and then we can, yeah. Better see it. This is video controls, case video controls, type video controls, type attention. But that's not the one we're looking for, yeah? This is a bit, we want to look in like video common or something, isn't it? We want to look in video common, I think, because this is video controls. Yeah, this makes that. Does anyone have any suggestions? Bartholomew, do you see something I'm missing? Does anyone have any suggestions? Am I missing something? Do we get an answer? We don't get an answer yet. Yeah, somewhere in here. Let's look. Yeah, actually, we were just right. We were just there. We were just there now. This is what I was looking for. So, get CSI link frequency, video control that. And it says this is a control. It needs a video control struct with an ID of video CID link. And then this is a query. It says that. So then it says try and get the link frequency from the source device. Video get control, device control, that one. And then this is a query. So it says if that fails, go to fallback. There should be some fallback here. Yeah. So if this fails, it goes down here, so it shouldn't get here. We should log where it's failing here. So let's go into video common and see if we can add some logs. Can we go into video common and see if we can add some logs? Is there any logs in here? Are we allowed to log in here? Are we allowed to log in here? Or is it only print K? Can we use print K in here? Log module. We can't do logging. So okay, let's go into video common and actually see if we can do some logging there. Video common, and then we want to do CID. command something like what? Something like Control F. No. Video command come all the way down to Control F. So video command come all the way to get CSI link. So get CSI link. Get CSI. So in here, so let's go into here. So I want to know if I fail in here. Log error. Initial video get CTRL explodes. Bartholomew was right. This one is an awesome one. And then I want to go down here to the fallback and say we're in fallback, and then I want to say log error. Oops. Fallback fails as well. Okay, so let's build this. Bartholomew, if you see anything, or if anyone sees anything, if anyone has a question, this is the best time to ask it. I'm gonna build now, so like Bartholomew says, my audio is gonna be cut off. And then let's see if we get any answers there. No answers yet. Okay, as long as it's failing in those two callbacks, we're gonna stop there. And then we have to realize how to, maybe we come back and we do a whole hour of building backwards from those two callbacks. Yeah. And then this is part one of this thing. As long as it's failing there. If it's failing there, then we know what is leading to that. So we can start actually building towards that. So this becomes part one. We got it. We know where it's failing. So, okay, cool. So the actual issue, we know exactly where it's failing. So the actual issue, I need to log in into the computer. So the actual issue is this. Video get control, dev control, ID pixel rate. So it doesn't find that one. and now it looks for pixel rate. Let's just go crazy. Let's go crazy. Oh my word! I promise I'm gonna stop. But I kind of now I kind of have an idea what's happening. So pixel. Do you see this? Do you see this? I think if we put this in, we might win. Okay, so kind of. I think so. Let's see. And where is this actually? Where is this? Init controls as well. This is the end of init controls. Okay, cool. So first of all, do we have a pixel rate in here? Do we have a pixel rate in here? This is what? Control. Do we have a pixel rate in here? Pixel. We do not have a rate. So that's a problem. That's a problem. There's a link frequency. Link frequency is half of that, so we can divide that by 2 and use it. So we can divide that by 2 and we have a pixel rate, and then we can just, I'm just gonna fake it. I'm sorry, but I'm just gonna fake it and see what happens. That's what I'm gonna do. I'm gonna fake it, and then we're gonna see if it works, and then if it doesn't work, we will figure it out. Init controls. Init sterols. Okay, cool. So now I want actually this to go back. I wanna go back here. I have a feeling we have to change quite a lot. 219. I think quite a bit of the thing actually has to change, and then it hits controls pixel rate. So I have to add it into the control F. Pixel rate. That's fine. It's in controls. So okay, I just need to go to CTRLs. IMX219. Yeah. So yeah, and then is it a struct? Video CTRL. So this is not a fix. This is us discovering what the fix needs to look like. I'm gonna build. I can't talk. Okay, cool. So that built. Let's flash it, and then let's see what happens. If that works, then it's either we're going to define that, or we're going to we'll see. I think it's gonna like explode big time. I don't see how that works. I think it's just gonna explode really a lot. Okay, cool. So it's not as simple as I thought. So the thing we need to discover right now is we need to discover how to specify, how to use the existing link frequency. It's not just a matter of providing a pixel rate and then going for that, which was kind of like a half-assed attempt at looking at whether that would be the solution, yeah? Because this camera already gives a link frequency. And by the way, the IMX219 is a considerably more complex sensor than the other ones because it's an 8 megapixel. It's a huge sensor compared to the other sensors that are available on Zephyr. Quite a lot of them have parallel interfaces, but this is like a pure MIPI only interface. So we're going to have to wait for the two titans to get back to me, and then we're going to discover. And as always, so this one becomes part one. Let's actually edit here and call this part one. And then, yeah, edit the title of this and call it part one. Part one. And yeah, this is going to be a multiple part series where we discover things and we go to and fro and we work with the community and we try and find out. I'm going to stop there today. It's been an awesome hour of finding out. It's really getting good. I remember when we did this on audio and memory with Bartholomew in the first time, we ended up learning quite a lot about audio and quite a lot about video. And it's always nice to have a beefy error like this, so you have to go back and come back and go back and come back a lot of times and see what happens. So yeah, this is going to be nice. We're going to push this through and see if we can actually land this Zephyr PR that we've started now discovering through. What we now need to discover is do we need to rewrite the whole thing? So do we need to start pulling up data sheets, or do we need to do some small part that someone knows and we don't know? And this is just what we're going to need to discover and then see how that goes. Thank you all so much for coming today. That was an awesome session. I'm impressed that you guys hung out, and yeah, thank you so much for showing up. Much appreciated. I'll try and stream again tomorrow, if possible from my new machine, so that we can see whether my audio and everything is working correctly. Yeah, as always, I'm Zach, and I urge you to try and fix things that exist and make real solutions for real people, and be daring. Thank you so much for coming to my stream today. Cheers. Unless anyone has any questions or final remarks. No questions, no final remarks. Thank you so much for coming to my stream. There's a Discord linked. There's a Discord community linked in the description. You can join us and ask more questions there, and then we'll cheers. We'll see you guys. Thank you. See you tomorrow for the next part 2 of this. Cheers.